I'm using the right formulas. I'm just,
I need to open the homework. Just give me a minute.
Yeah.
With the sign, you say homework part 1, right?
Mm-hmm.
Number 4 you're already doing.
Yeah.
Okay, I think I just can copy text. Well, things to keep in mind. What kind of a lens?
It's the convex one, so it disperses. The focal point is behind the lens.
In the image, which is smaller than an object.
Mm-hmm.
And an image is located. Okay. How would you draw the continuation for this ray, for this lens?
So the focal point would be behind the lens. So So you kind of have the imaginary projection go down towards the focal point on the right side of the lens, and then you would extend the reflection going up.
That's a lens, so it doesn't reflect.
Oh, okay. So then.
That's a lens. It transmits. Yeah. It transmits light, and light should go well. If the lens wouldn't affect it, it would just go straight ahead.
Mm-hmm.
If the lens affects it, there are basically 2 options: closer to the principal axis or away.
Mm-hmm.
So what would you choose?
Would it go closer to the principal axis, or?
Well, you said this is lens that you said disperses light.
Okay.
Well,
so
the better term, the actual term is diverges light.
Diverges, okay.
So we didn't talk about it today yet, but this is how it should go.
Okay.
Because that's the lens. And actually, no. This is wrong. Because this is the lens, not a mirror.
Mm-hmm.
Yeah. So this lens converges light.
So it's like opposite for mirrors and lenses then?
Yes.
Okay. Oh, okay.
So if you take a piece of glass,
mm-hmm.
and then you cut out some part of it, so you will make it look like this.
Mm-hmm.
That's what we call concave, like cave.
Mm-hmm.
But this lens would diverge, disperse light. Convex, this was convex mirror, but this is not the mirror, this is the lens. This is how you polish it.
Mm-hmm.
And this lens will converge
Okay.
the light. So for this lens, all right, this lens, with this kind of its shape,
mm-hmm.
light should travel through the lens bending toward the principal axis. So, but this type of a lens can actually make a normal real image if your object is far enough. An image would be inverted and real. That is not the case. So, question is, how can you achieve the situation in your problem?
Right.
And it has to be placed very close to the lens. So, but not as close as mine. So the image is on other side. Okay, see?
Mm.
So if I would place it very close, like I just did in this picture. Okay, this ray goes like this ray goes like this. So now they don't converge.
Right.
And you would get an image on the same side, but not is real, virtual.
Mm.
So that's also not the case. So now you know how you have to place your object. It has to be between focal distance and doubled focal distance. Here, in that case, on another side. Oh, stop. No, it's already smaller. So, no. Wrong. These not the cases in a problem. This is smaller. This is on another side. So that completely fits the description. Convex lens, image is small on another side. You see? So this is our diagram. And now we just need to say what? We need to say that the magnitude of the image is equal to 0.75 of the size of an object. And the object is located 23 centimeters. Oh no, again, the image is located. So this is what we know. 26.3, wherever you have. Cool. Now, the equation. Well, this equation has two unknowns. We don't know the focal distance, we don't know the image distance. This equation only has one variable, and because this is a real image, this is a positive number. We should use a positive number.
Okay.
So we have to use this equation in a certain way. For the magnification.
Right.
This equation we know doesn't, well, all equations are the same for lenses and mirrors. It's an optical device. This is the definition of the magnification, and this is how it's related to distances. So my question to you now, how do you use it? What number do you write? What should be equal to?
0.75. It would be negative 0.75 because.
So the magnitude is
The
given to us,
magnitude is
but the actual value is supposed to be negative
Okay.
because the image is inverted. So this, well, you don't really need this. You can just take this part and write negative 0.75 times the size of an object divided by the size of an object equals negative 1 times 26.3 divided by the object distance. See?
Mhm.
And now what can you do?
We could solve for D-O.
Exactly. That's going to be 26.3 divided by 0.75. Oh, you have your numbers.
Right.
But then you can plug this answer into this equation and calculate the focal distance.
Okay.
That's exactly what you're looking for.
Alrighty. Sounds good.
Ooh.
Thank you.
And you see, we need to read carefully. All information is important. For example, focal length is negative, so it's diversion. And well, conversion. Well, theoretically, you could now solve all problems.
Yeah. And I was able to get through most of them. This one just tripped me up for whatever reason. No.
Because it has many elements that's supposed to be
Right.
put together, you know.
Yeah. All right. Thank you.
You're welcome.
Take care.
Bye.
Bye.